Alright, we're working back again on 9.1 exponential functions, and this is the second of the two videos for 9.1. Make sure you watch both these, take notes on both these first. So, just as a review, f of x equals a, b to the x power. These are exponential models. A is our y-intercept. It's also our starting value. So it's a y-intercept, it's a starting value. B is our base number. And it's how we tell whether it's growth or decay, right? So growth or decay. And we're going to use 100% with this thing for growth or decay. And we'll just have to figure out what growth is versus decay is. And then our x is our time interval. So, example 1, let's talk about that one we had at the end of our last set of notes. If untouched in 4
years or in 8 years. So it says it looks like this is growth because it says grow. So we're going to start with 100%. We grow by adding things to it. We're going to add our 5%, which was at 105%, which in decimal form is 1.05. Okay, so let's write our equation. So we have y equals our starting value is 1,000 times our growth factor of 1.05. all to the x power. Remember, x is just our time interval here. So we're going to type in y equals 1,000 times 1.05 to the x. Our x for this first one is 4 years. Looks like we'll do a first one and a second one. So this one is just the first one. So I'm just going to type this straight into the calculator. I type in, let's see, 1,000 times 1.05 in parentheses to the 4th power. Yup. Which gives me, not 1.5, Mr. Seaman, 1.05. 1,000 times 1.05. It'd be great if we had a 50% growth a year. That'd be awesome. Okay, there we go. 5,000 is a little bit too high. So, typo, make sure you type it in correctly. So, I get a total value of $1,215.51. 5 or above, give it a shove, 51. Okay, let's check what happens after 8 years. So 1,000, 1.05 to the 8th power. Okay, then let's make sure we type it in correct this time. 1,000 times 1.05 to the 8th power. So if we just leave it for 4 more years, just don't touch it at all, we get, what's that, like 250 bucks? That's pretty awesome. So, moral of the story, if you can get 200 bucks for 4 years, yeah, man, just leave that alone. Imagine how much you get by the time that you retire or some nonsense. Alright, so, example 2, a certain car has a depreciation of 18% per year. If the original purchase price of the car was $32,795, how much is it worth in 5 years? How about 10 years? So I picked 5 years because that's usually when we get rid of our car loans, right? So usually we have a 5-year loan. So let's talk about a growth or decay. We notice that it says depreciation right here. And we notice that it says 18% depreciation. So if we're depreciating, that's a decay. That's a decrease. So we always start with 100%. We're going to decrease by 18%, which is 82%, which is 0.82. Okay, we know we have a starting value of 32,795. So let's write our equation. So y equals our starting value times our base rate of 0.82. And notice for depreciation, it doesn't make as much sense. For a growth, you can definitely see like the 5% growth. But for this one, you're going to have to subtract to get your decay value. So then we have to the x power. Okay, we're looking for 5 years and then after 10 years. So y equals 32,795 times 0.82 to the 5th power. Okay, let's make sure I type this in correctly this time. 32,795 times 0.82 to the 5th power. Gives me a value of $12,158.41. That's a lot of depreciation. I mean, that's like a third the cost of the original car. Okay, so let's do y equals 32,795, 0.82 to the, instead of 5 years now, we have 10 years, which is going to give us 32,795 times 0.82 to the
10 years. Oh man, that is seriously decreased. $4,507.61. That is a serious decrease. I mean, this is like a third of the price, and that's like, so somewhere between
an eighth and a seventh of the price. That is a significant decrease in the amount of time. Okay, so it says keep your car in shape, man. Keep your prices up. Alright, the half-life, how much is left after 10 days? What about 15 days? So, we know a half-life, right? And from science, we know that's a decrease. So that's the decay of how much of it left over, which says we're moving 50% every single time, which shows we have 50% remaining, which in terms of decimals is 0.5 or 0.50. So it tells us our starting value is 4 kilograms. So y equals 4 times 0.5 to the x power. So here's the tricky thing about half-life. Half-life is not something that you can just plug this number in for. We have to figure out how many half-lives happen. So at 10 days, if it happens every 10 days, if it happens every 5 days, right? That is 2 half-lives. Half-lives. If it happens over 15 days, divided by a half-life of 5 days, that is 3 half-lives. Okay, which I don't know half-lives versus half-lives. I think it's half-lives. I think that would be okay. I'll have to actually try a teacher. Regardless, in our x values, we're going to plug in 2 and we're going to plug in 3. And this is just because it says the term half-life. We have to figure out how many of those actually happened before we can actually figure out our value that's left. So y equals 4 times 0.5 to the x power. Our first x for 10 days is going to be 2 half-lives, because it happens half for 5 and then another half for 10. That says half of a half. So we do 4 times 0.5 to the second power is 1 kilogram is left after 10 days. I'm just writing this after 10 days because it's not as apparent when I do this math which one of these is for. So it says y equals 4 times 0.5 to the third power. So 4 times 0.5 to the third. It's another half-life, which says we should have half of this, which we do. We get 0.5 kilograms after 15 days. So this is helpful. Yeah, we get nice answers here, but if you wanted to find like 18 days, you could say 4 times your 0.5 to the 18 over 5, which would give you like 0.32 kilograms. You could say like after 33 days, like how much is left? 4 times 0.5 to the, let's see, 33 divided by 5, because that's our half-life interval. It's like 0.04 per kilogram left. So yeah, I kind of rigged it up for this last problem to have some nice numbers. But you could rig it up for any number you want. You could find out any value after your overall time interval. Okay, so make sure you have all of these notes written down, and then get